Okay, so we have another problem here. This is linear equation word problems. So let's read through it. It says when a number n is increased by 25% and 11 is added. Well, I know I'm going to be adding 11. That's the easy part. Then the result is 51. So that's equal to 51. So what is this when you take a number n and increase by 25%? Well, let's pretend we had, I don't know, a bucket or some container that has n inside. And this is how it has n something, like maybe it's jelly beans or something. We have n number of them, okay? So if the bucket is completely full, the container is completely full, we call that 100% full, right? It's 100% already, right? So what does it mean to increase it by 25%? What are we going to do? We're going to go up an extra 25%. We're going to increase it so that now that n, we have now, instead of just n, we have 100 and 25% of n. I'm going to put and. Oh boy, you can't see yellow, can you? We'll go back in here and just do that. And so we're getting 100% and 25% of n. So now just remember this. If we say, what is 100% of n, question mark, then this translate into algebra like this. X, what is x? Is equals, remember u is dumb. Okay, 100%. Well, what is 100%? It's 100 over 100, right? Which is equal to 1. I'll just write that as 1. And of is times in these situations. And n, we're going to put n here. So x equals 1 times n, or in other words, x equals n. So that's, now we know what is 100% of n, and the answer is n. N is 100% of n. So we're going to take n and we're going to add to it 25%. Oh, hold on, let me erase that. Let me stick my colors and stick with the colors I've been using. Get back to red here. Sorry. So this is n. That represents 100%. That represents this portion right here. That's n. But now we have to represent 25%. So we would do the same problem here. What is 25% of n? And then this would be 25 over 100 instead of that. It's 25 over 100. And probably the easiest way for me to write that is as a decimal. That's 0.25 times n, not 1 anymore. We're done with that problem. So 0.25 times n. So 25% is, this is how we write 25% of n. So this is the increase, plus 0.25 n plus 11 equals 51. So let's write that equation. Hopefully they'll like it. We're going to put in n plus 0.25 n plus 11 equals 51. Okay? Try to do one more real quick. Let's just see. McDonald at a farm. All right, I'm going to E-I-E-I-O my way back to the other screen because I can write better on the other screen. It just seems to work a little bit better. So Control X that. And I'm going to go to my next screen. Control V. There we go. All right, Control X is cut and Control V is to paste. So here we go. So if McDonald has a farm with a certain number of orange trees, he had to cut down 5 trees to control the insects. Boy, to do these, you just kind of got to see them, right? So he's got a bunch of orange trees. So these are orange trees, right? And he's got a whole bunch of them. I don't know how many. He has a bunch. So I'm just going to draw them all like little, there we go. Those are trees like that. And he's got more and more and more and more till we don't know how many. Okay, we don't know how many. But we know he's going to cut down 5 of these. So he's going to knock down 5. So there was one that he got rid of, another he got rid of, 3, 4, 5. Right? He gets rid of 5 of them, right, to make room, to control the insects, okay? So now of the remaining tree, each of the remaining trees produced 210 oranges, producing a total harvest of 41,000. So what was left was able to produce 210 each. So let's just say this. It says, write an equation to represent the total harvest in terms of the initial trees. I know that I ended up getting 41,790. But it wants us to do it not in terms of the total trees after the cut. It's the total trees before the cut, which they're calling T. That's what initial means, the first number. So the first number, initial, was all of these plus the 5. And what we did was we took away 5 from them, right? So there's all the trees that we started with, and we took away 5. Now once we reduce that number by 5, we have to multiply that by what? 210. And then because each one gets 210, so it's 210 here, 210 there. So why does it multiply? Well, if you look, we're adding 210 for every tree, making T minus 5 trees times 210, so 210, or rather T minus 5 sets of 210 trees will equal 41,790. So there's my equation right there. I'm going to put that one in. And that's probably all I'm going to do on this video. So we go 210 times T minus 5 equals, what was that number again? 41,790. Oh, it was right there too. Equals 41,790, right? Okay, let's check that answer. Boom. And that's how those are done.